Let's say that we're told that the position of a particle can be figured out from, or the position of a particle as a function of time is given by this crazy expression. The position could be positive or negative, and this expression is t minus a times a minus t times t minus a times t minus b. All of that over the square root of a squared plus b squared. And they also tell us that c is greater than b is greater than a is greater than 0. So given that information, we have two statements right over here. We have the position at time c on the left-hand side, and over here we have the number of times that our function is equal to 0, the number of times that p of t is equal to 0. What I want you to do is pause the video right now and think about which of these statements provides a larger value. Is p of c greater than or less than the number of times p of t equals 0? And I guess a third and fourth option would be that you maybe don't have enough information to figure this out, or maybe that these are equal. So I encourage you to figure that out right now. Which of these are larger, or do you not have enough information, or are they equal? So I'm assuming you've got given a go at it. So let's think about each of them. So let's think about what p of c is. So p of c is going to be equal to, right here, I don't want to arbitrarily switch colors, which I sometimes do. P of c is going to be equal to, let's see, it's going to be c minus a. I'll do this all in this one color. It's going to be c minus a times a minus c times c minus a times c minus b. All of that over the square root of a squared plus b squared. So what do we know about this quantity? What do we know about this quantity right over here? Let me highlight all the c's here. So c minus a minus c minus a, c minus b. Well, they tell us that c is larger than a and b and that they're all positive. So maybe we can come up with some statement about whether this thing is positive or negative, whether this expression is. So what's c minus a going to be? Well, c is greater than a, so this is going to be positive. What about a minus c? Well, a is less than c, so this is going to result in a negative number. C minus a, well, this is going to be a positive again. And then c minus b is also going to be a positive. C is greater than both b and a. And what do we have here in the denominator? Well, the square root of a squared plus b squared, well, this is going to be a positive value. So what do we have going on here? Here in the numerator, I have a positive times a negative times a positive times a positive. So what's that going to be? Well, that's going to be a negative. A positive times a positive times a positive is positive, and then you throw that negative in there. So you're going to have a negative over a positive. And what's a negative divided by a positive? Well, that's going to be a negative. So we don't know what this actual value is, but all we do know is that this provides us with a negative value. So if this ends up being a positive value, then we can make a statement. If we just say, hey, this is a negative value as well, then we might not have enough information. So let's think about the number of times p of t is equal to 0. Well, p of t is equal to 0 whenever the numerator right over here is equal to 0. And when would the numerator equal 0? Well, I have the product of this 1, 2, 3, 4 expressions. So if any one of these expressions is 0, then the entire numerator is going to be 0. So let's think about how you can make these expressions 0. So the expression could be 0. This will be 0 if t is equal to a. This would also be 0 if t is equal to a. And this would also be 0 if t is equal to a. And this would be 0 if t is equal to b. So there's two values that would make two values for t that will make this numerator equal 0. T equals a or t equals b. So there's 2 times. So the number of times that p of t is equal to 0 is 2. So now let's answer our question. What is larger? The number 2, the number positive 2, versus some negative number. Well, 2 is larger than any negative number, so this is the larger quantity.